So begins another draft physics video production. Just thinking whether I should give some back history. I did make a video response to Fractal Woman, but the video froze. So I might do that over again, but who knows if it's worth the trouble. We'll find out after I'm done with this video, I suppose, whether I feel like making any other videos. Or videos to make. So anyway, alright, comments, and we have some responses to previous comments, and I just thought that was sort of interesting. So Perv Action asked this question about sort of a free energy question. He doesn't think so somehow, but that's pretty much what it is. So I thought I would just clarify another way of understanding. Oh, okay. Blah 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 blah. Whatever. I don't have that. I usually don't have messages pop up, but anyway, it doesn't matter. So where was I? Another guy working on animation, which is nice. But anyway, where was I? Anyway, I was in the middle of something. Yes, so energy. So I thought another way of understanding it is, as I've stated in the past many times, energy is sort of defined by proximity. Like if you bring electrons in or together, you're obviously creating obvious pressure because they don't like each other. And so proximity is connected to energy in the sense that you can think about like you being in outer space and you weigh less. So in a sense, your weight changes just because your location changes. So you get closer to the Earth, all of a sudden you have more energy, you can do more work, just by changing your position in space. So in a sense, energy is just the byproduct of that proximity on this small scale. So I would say that E equals mc squared might be a generality, generally true, but that there's a specific reason that there's a connection between mass and how much energy you have, and the reason is forces act on you. And if there's no obviously if there's no force acting on you, then you wouldn't have any potential energy or any energy at all, because you couldn't get close to something, essentially, effectively. And so in a sense, when there is a nuclear release of energy, just saying, this is just a draft statement off the top of my head, but you know, they sort of invented some, like neutrinos were sort of invented merely because there's an absence of the appropriate amount of release of energy. It doesn't fit E equals mc squared precisely when two uranium, when the atoms are broken apart to create two barium atoms or whatever it is. There's not just enough stuff doesn't quite come out. It's a lot, but not quite enough. So they invented neutrinos to fill the gap, essentially. And you could argue that maybe there isn't any gap, because what the bomb is doing is actually creating more distance between the particles, and the more distance you create, the less energy they have innately, in a sense. And so unless you account for that change in their position, you might miss some piece of the energy. It's probably in the equation already in a sense, but I'm just saying it could be. But anyway, moving on. Alright, so Superior Mind basically says, wondering what you have in mind when you say set up multiples of. So this is to set up some sort of multiple of some sort of photon breaker, okay? And as I attempted to explain, photons they take more energy to make, you could argue, or more circumstantial, specific circumstance, a complexity. But they don't innately carry a lot of energy in the sense that they're a tiny percentage of the energy in the universe. It take a lot of photons to move an object, as I've attempted to explain. So to counteract gravity, you have to counteract a lot of force. So in spite of it being a weak force, it's an incredibly dense force. And photons aren't a great anti-gravity device, frankly. You're better off using something magnetic, because then you take advantage of the fact that one of the forces is repulsive in the field. Okay, and if you just use those repulsive forces, you can maximize your potential to move something. Well, anyway, so just a weird. I don't know how I'm possibly alluding to free energy here. Quite the opposite. Well, I don't understand how it's quite the opposite at all, but whatever. Whoever does it can pump in as much electricity, wind, fossil, etc. as they want. The point is not to cheat, but to use stuff like magnetism, high energy beams, and high enough temperature differences to move small objects. So you're saying you don't, you're just saying it's not even free energy. You're saying I want to find expensive energy. You're using movement to cause movement. So I don't understand exactly. And you're talking about moving some little thing with a whole bunch of energy. So it's like the opposite of efficient. But I don't know I can't possibly understand what you're talking about. Something to do with shooting lasers at a balloon I don't know. It doesn't make any sense. And then there's somebody else in the comment thread, so it doesn't really matter. But yes, quite incomprehensible. So we'll just move on. So we have a little bit of the troll here. So the Gelfield is back as different names, of course, but anyway, just making his little snarkyism. So we'll read some of them. What the hell? Lack of drag leading to deceleration of orbits and planets. So again, this is on the drag subject. If you have something bouncing back and forth inside you view hard enough, it will make you swim against the current. Isn't it obvious? So again, you go to the trouble to explain it, and it's just a wasted trouble, right? I mean, clearly a photon is doing something. Now, if you don't believe it's doing what I'm saying it's doing, then fine, it won't work. But if it's eternally moving, and that's my argument, that the little photon-y things, the forces, are eternal. They don't ever annihilate somewhere. They don't just stop. They're always just captured. So like a little hummingbird or something that's always flying. They're always flying. It's just a fact. So that has a consequence if you capture it. Just like sort of the Earth has a consequence when, say, it was captured and created an elliptical orbit. The ellipse is a byproduct of the unevenness of the force that went in. The initial force is still in the shape of the Earth's orbit, you could argue. And the shape of the orbit might have an effect on how the solar system might move. And so if that's not physics to you, understanding those consequences, fine. You want to do some other kind of puzzle, fine. Go do some other kind of puzzle. I'm just saying I set up the circumstances, and you're not making a counter argument how it doesn't work. You're just mocking it and saying it doesn't work through some kind of mockery. You can't do better than that. I mean, that's the best you can do. And for what purpose? Again, just to deny a physical circumstance that's true. If the photon has perpetual energy, and I trap it between mirrors, it has a consequence. You're saying it doesn't. If I made perfect mirrors, right? The only reason why we can't capture photons right now is because the mirrors defeat us. Okay, unlike what they have as expectation as LIGO, mirrors aren't perfect. Okay, so eventually the photon will fall between the cracks and it won't reflect. So there's a certain number of the photons that are transmitted by the mirror, and there's just not much we can do about that with current technology. So we can't trap photons, for any period of time, because we can't make a trap. But if we theoretically could make a trap, How was my argument in some way flawed? The initial momentum is the momentum, and it is trapped. And the thing will move, and then it'll stop, and then it'll move, and then it'll stop, and then it'll move, and then it'll stop, and that's going to happen. And I called it essentially maybe perhaps the smallest motor you could make out of physical objects, besides the motoring they have. Is there some other way to capture the energy of a photon in a simpler manner? And I'm sort of arguing that would be the simplest trap for a photon. And you don't think that's an intelligent question? Okay, but could you articulate how it's not intelligent? No, you can't. Because you're a piece of scum. Anyway. Okay, Adrian Fly. Not if it's bouncing back and forth. Something pushing you against the current can keep you going against the current. If it is going back and forth, that won't work if you're going against the current. I'll watch Mendham's last video and see what his hypothesis is, though. So, unfortunately, Bob can't really instruct Adrian Fly, the troll, Gelfield, because he doesn't understand it either. But I mean, it's just, it's as simple as the argument, right? I could throw a sack of potatoes into a wagon, and what's the wagon going to do? Well, it's going to go in the direction of the sack of potatoes was going. Now, what it's not going to do is bounce back and forth, because I didn't create a thought experiment for you explaining how it would be frictionless and it would slide. And then even if I did that, you'd realize that the sack of potatoes is going to lose momentum. Well, the key point is that photons don't lose momentum. They don't become small or ineffective or any of that stuff. Their momentum doesn't change. They are eternal. Now, if you don't believe that, just say, I don't believe photons are eternal. Okay, fine. Then this thought experiment is not relevant to you. Oh, God. Bob the Fly, can you explain his hypothesis? I admit having trouble understanding. So they're saying they don't understand that I can't make a physical object on Earth out of matter, okay, that has an internal velocity unless I throw it in space, right? So if I put it in space, though, it's still a mass, and it's still, I can't make a mirror for it, right? I can't make a mirror where it perfectly reflects off of a surface without imposing any momentum. So again, I'm still limited by the fact that I can't duplicate the physical structure of a photon. That's not my fault, okay? So you want to describe the real universe by using objects in our universe, right? So the little universe, obviously things have properties that I can't make out of things in this universe. I can't crumple up a piece of paper and say, there's a proton. Now I could give it a charge and I could do a few things to make it act a little bit like a proton, but it's still not a proton, right? You understand that, right? It's not going to have exactly the same properties. And you're basically just saying, well, it doesn't matter. Exact properties don't matter. They're irrelevant. Real properties don't matter. They do matter. And then you're again just mocking the conversation as if somehow it's unworthy. Because you have it all figured out already. But you won't tell us what you have figured out. You won't tell us what your vision of the universe's function is. Because you're a coward, a pathetic coward. Because you'll be mocked. Okay. Not yet, I can't. Usually have to hear a genuinely new concept a few times before a light bulb goes on upstairs. Well, let me know when you get it, that photons aren't cue balls. So yeah, they're going to have the rules are going to be a little bit different. All right. All right, so that's the blackboard thing. So Gelfield had to add his little joke here, about the Cope thing or whatever. Unless you're going by mental age. Right, and you're the one who can't do any more complex puzzle than, smashy red square thing into round hole. All you can do is that little hammer thing. And I bet you never got any of them right? You never put the round thing where the round thing goes. You're you're probably a butt fucker. Anyway, let's see. So we did this a Drac bullshit. Okay. And he says, Drac said, okay, so that one we already did. We don't have to do that again, thankfully. No opposition here. We did that before. Alright, so any vids or audio of Tesla? Well, there's no videos of Tesla as far as I know. It's talking videos anyway. So you're out of luck. And frankly, I don't think I haven't seen any audio files either, which is kind of surprising because, it's not like they didn't invent the tape recorder before he died, and he was a bit of an ego guy. He was always posing for pictures, but he was pretty old, so maybe he didn't want to be recorded. But anyway, the car or the inventor, so yes, that's kind of useless tripe, so whatever. Alright, so live free or die. Here we go again. What do you mean by an angle in Maxwell's equations? So, I'm not the one stating, okay, that Maxwell's equations have anything to do with a wave. Alright? Obviously, you doing this curved liney thing and saying that's a wave doesn't mean anything because it's still just a clump. And the stuff on one side of the clump is, cancels out the stuff on the other side of the clump. You don't need the clump. All you need is the on and the off part, and that's the only part of the equation that matters, is the frequency. The turning it into a sine wave has no role to play. But the point is Maxwell's equations are derivative things, right? So they're equations that lots of people replace the components. And what they can do is they can replace the component that has the dt in it and the d whatever, the distance and time, and they can replace that with a hunk of Schrodinger crap, okay, and say it's the same equation, that those things are equal, and plop the wave equation into a Maxwell equation. So I've seen, that's what they do. So that's was sort of what I was responding to. But yes, I agree. They're not wave equations. There's no equation for a wave. There just isn't. There's no. A wave is especially in an interfering wave, is a geometric construct, and you really can't just formalize it, not in any rational way. There's a wave equation. I mean, not without understanding all of these things are specific variables, controlling specific things and understanding what you're supposed to do to them to combine them. They have to be combined in a special Pythagorean way, which isn't going to be in the formula. There's a wave equation. You're right that it doesn't have to be a sinusoidal. There's a billion different solutions to it. I don't get the whole angle stuff. Well, I'm sorry. I'm just saying I'm getting harassed to explain why it's not a wave equation. I'm just pointing out, though, if you try to turn it into a wave equation, it's still not a wave equation. Schrodinger's equation is no wave equation. It's a frickin' sine theta equation. So even when they try to say something's explicitly a wave equation, it's still not a wave. Because the only reason why they use waves is to create interference. And interference is geometry. And so then you're back to an angle difference. So all you're saying is it's an equation that accounts for an angle change. And so that's all that's in the equation. So they shouldn't pretend the equation proves it's a wave when it doesn't. You're convincing me. Well, that's good news. I'm having trouble around your channel, though. There's way too many videos. Couldn't you make a couple just summarizing and putting it all together? Well, yes, I already did that. So you have to look for playlists, I think there's a link to the playlist right in the bottom of the video, but whatever. Yeah, I'm sorry. It's a lot of subjects, physics. I read your introduction in your website, but it only talks about force bits and doesn't mention diffraction or interference and all that stuff. Well, there is actually at the bottom of the page, I think, a link to a two-slit analysis, but whatever. Yeah, the written stuff isn't at all complete, and frankly, the second half shouldn't even be read in a way. So fine, I got to fix that. Yeah, I know that. Writing physics is kind of difficult. But anyway, but I have done videos where I explain these words, so it's a definition video. It's got to be in there somewhere. But I've certainly talked about diffraction and interference an awful lot. Also, what's your stance on relativity? Well, I obviously don't think time is ever broken, and all you can do is break clocks. Motion breaks atomic metabolism. It disturbs it. And that can look like cryogenics. It can look like you slowed something down. But it might just look like you're dead. So I'm arguing that if we accelerate human beings, gave them lots of velocity, that it would probably kill them, because there's too many complex mechanisms that are dependent on some sort of regular motion. You can't speed them up too much or they break, like a clock, in some kind of way where it doesn't just slow down, it breaks, it just doesn't work anymore. I mean, pendulums don't just slow down in space, they break as a clock, you know. Sand dials, or, you know, whatever. Sand dials? Well, you know the one, whatever. Your video on lensing made sense to me, but the time dilation one didn't. Well, I'm sorry that you can't understand multitasking. I mean, that's essentially the argument. When you require an object to move, you're requiring a system of electrons and protons that are now jiggling a certain way, to jiggle a certain way and move somewhere. So that means they have to take time out of their jiggling to jiggle that way. So if you were dancing and I told you to move while you were dancing, you couldn't dance as fast. You didn't tell me you can't understand that? Come on. I sort of don't believe you. You know. Okay. The whole angle stuff is basically a statement that light is made of real things affected by matter. I don't know if I might even say it the other way around, but fine. Obviously, it is captured or reflected by matter. And what is conventionally interpreted as a wave are really compound deflection angles. I don't know about the compound part, but maybe. Yes, the point is there's nothing waving. It's a discrete particle moving on a ray path. It's not a wave. If atoms were filled with tiny grains of rice and empty space, the tiny grains of rice would cast bigger shadows farther away the projection area is. Well, that's sort of true, yes. I don't know if that exactly tells the story, though. Like shadow puppets, both the source light and the cast shadow spread in cone shapes. The outer edges of the cones are the angles. Oh dear. Yeah, no, I don't think that really gets to diffraction. Clearly, there's more to it. You know, the photons do change in specific ways. They have to interact with electrons, so it's not a shadow deal. He has playlists like subjects and videos named overview, etc. I'll throw this in real quick somewhere. Boston YouTube comment system. I elaborated on the thought experiment about push gravity beams. Push gravity beams. So that's the comment I read just a minute ago that I couldn't understand. If you, Gary, want to dig it out, it's below the Piro video, November 30th. Why would I want to push? I don't know. You elaborated on the thought experiment about push gravity beams. Well, it didn't show up in this comment section, which I think it really has to if it exists. So something happened to your comment. It's not in the spam folder, so I don't know what to tell you there. But I don't know why you would want to elaborate on it. the whole point is, if you want to defeat gravity, guess what? You're going to need something massive to do it. There's no, you know, gravity, big shadows are created by big objects, and you're not going to create a big shadow with a little object. So it's not going to be a good source of energy, trying to attempt to make gravity. I mean, energy is just imbalance. Again, so you have to imbalance a system before you can have something called energy. And the key is there's already a bunch of imbalances flying all around us right now, so the smart thing to do is just try to take advantage of those as efficiently as possible. Alright, so Gelfield, let's see what he says. Do you realize that there are more angles than 90 degrees, right? Yes, so what? I mean, I've drawn more angles than that. I've sort of pointed out that, you know, this will come up. I mean, this is sort of an important little bit, so I'll draw it in terms of this understanding how angles are created by this absorption theory. And I sort of pointed out that you're more likely, just as there is drag, there's a concept where you're more likely to hit stuff that's moving against your direction. So if you're moving into something, you're more likely, if it has stuff in it and it's moving in directions, you're more likely to hit the stuff, you know, these would be littler arrows actually, smaller arrows. You're more likely, so if this was just a way of drawing probability, you're more likely to hit the stuff moving in your direction than you are hit the stuff moving with you. And so over time, that would mean that if these were replacements, as I'm arguing, that what goes in, this goes in, and one of these comes out. So obviously the more likely thing you're going to hit is this one, so this one would go out. Now the faster I move something, you could argue that there aren't any more of these to hit, and you're going to start hitting these and some of these other stuff. So as you're going, as your momentum increases, these exchanges get less and less efficient. So when it's stopped, you have a high likelihood of exchanging this, okay, for this. But the faster you're going, you're starting to exchange, say, this for this. And then eventually you might exchange this, okay, for this. So you're not getting back as much as you put in terms of in the opposite direction. The imbalance is getting less and less and less. And eventually, if it's going really fast, you're going to be exchanging this for this. You know, and so the difference is getting smaller and smaller and smaller in terms of what you're likely to hit based on what's likely to still be inside this thing. So as this thing speeds up, this lopsidedness turns the opposite way. And as I alluded to a moment ago, that probably has something to do with elliptical orbits. You know, what you're basically doing is changing the orbital path, and now it's ellipsing this way. And ellipsing might have everything to do with procession through space and movement through space for material objects. That's how they move through space, is by creating those imbalances. So I mean, the idea is that as something's moving faster, it starts to send out a lot more perpendicular 90-degree angle stuff, and you know, it's variance. That's all. What if two force bits of opposing color collide at 76 degrees? Well, I already went over some of how these could be compound angles, so that's not an issue. Do they still go perpendicular? No, they go at 76 degrees, and the other thing still goes in at the 180 degree, or whatever you want to call that, to that. Or what? So these are all questions that I have answered. And if so, perpendicular to what? The 90-degree rule only seems to be well defined for particles whose trajectories are exactly parallel and meet head-on. No, the 90-degree rule, there's no real 90-degree rule, but this rule of the force being produced perpendicular to the action is part of how electricity works. But the point is that it doesn't have to be perpendicular. It just has to, I mean, it doesn't have to be perfectly perpendicular. It can go this way or this way, and again, those will be combined, added up. So if you have the same number going this way as you have this way, those will be added up to look like this in the end. The only component that matters is the component in this direction. That's the only one that's going to be measured by something being affected by it. It's how much did it push it up. That's the part we measure. Speaking of which, listen to this trite. Makes me want to order some head-on. Applied directly to forehead. Head-on, applied directly to forehead. So this is the kind of stuff that it just says, okay, I'm just going to block you, right? I'll read your crap and then you're blocked. I mean, just waste everybody's time. You've trolled every comment on here. Well fucking done, genius. That's his purpose. So he thanks you for the compliment that he accomplished his useless purpose. Why is there a speed limit in the universe? I didn't establish a speed limit. So this is, again, nobody can paraphrase anybody honestly. Where have I said the words, there's a speed limit to the universe? I'm just saying that clearly the bits are defining the limit. I'm saying there's no way to make movement except through the force. The force always travels the same speed, so it's obvious that if all I'm doing is making exchanges, I'm catching hummingbirds in a cage. The cage weighs something. So when the hummingbird goes in, the cage can't move as fast as the hummingbird because it weighs something, and the hummingbird now has to drag it along. So it goes 1/1,000,000th of the speed of the actual hummingbird's flying. He sticks his head through the rail of the cage, and he flies and flies and flies, but he's got to drag this heavy cage with him. All right. Now, if I fill the cage with hummingbirds, I can go a certain speed, but I still have the drag of the cage. So I can never get to the same speed that the hummingbirds can fly. It's just impossible. So that's the rule. So that's why there's a speed limit in the universe, because the only thing that makes things move, the hummingbirds, are the fastest things in the universe, and there's just no evidence they go any faster. It's like asking, why is there a speed limit on hummingbirds? Yeah, well, there's a speed limit because, yes, they weigh something, and they have to drag it along. Anyway, you've conceded that photons carry momentum. I didn't concede it. I've asserted it from the very beginning aggressively. You're the people who say photons aren't real things. That somehow they have no mass or some kind of bullshit. It's not my statement. It's your statement. Anyway, that atoms are composed of force bits moving the speed of light. Well, that's not what I said. What I said is they're captured. I said they're trapped. Obviously, the trap has to weigh something. The trap is a real thing. Okay, the trap isn't the force. So whatever the trap is, whether the trap's a simple membrane or a simple, even if the trap is just made of density, it means the density can't change. Something about the trap can't change, or the trap isn't a trap anymore, right? So that's all. But clearly the maximum speed regardless, even if I can convert the trap into hummingbirds, I still can only go the speed of a hummingbird. A maximum speed. Alright. I mean, again, is that puzzle too complicated for you? Anyway, light and their velocity can change when the photons hit it. Okay, so the atoms are composed of force bits moving the speed of light. That's only part of their composition. And that their velocity can change when other photons hit it. Well, as I pointed out, it saves a register of its history. The boat doesn't have a motor, essentially, okay? The electrons and protons don't go anywhere. They go where the force forces them to go. And they go there with their own momentum, in the sense that to undo a force, you have to decelerate. And that's a process. So you have to go through the process of changing the boat's momentum. And that process takes a little bit of time. So how can a photon moving the speed of light speed up when another photon moving the speed of light hits it? So never have I suggested any such thing as a possibility. So just more nonsense. How could it ever catch up to the other photon? So again, I would never suggest that two hummingbirds flying in the same direction could ever catch up to each other. Wouldn't your model imply there isn't a speed of light? No, it wouldn't imply that. And that light can speed up and slow down when it encounters other photons. No, as I've told you, it's exchanges. You haven't heard that word 675 times? Like the word trap? You haven't heard these words? I mean, this is just preposterous nonsense. You just don't want to argue my theory, right? You want to argue somebody else's, but somehow they have you blocked. What, you want to argue with Ken Wheeler or something, and you're just so impatient. So you're forcing my theory to be some other theory? I mean, you really have no excuses. Also, if force is the same as light, light is a force. That's right. It's just the stuff with a frequency. They're stuff, little bits. I mean, I've drawn it so many times. Little cannonballs. Yes, and cannonballs can be in short rays or they can be in long rays. And if it's a short ray, it won't be a photon. It won't be a visible one, a detectable one. You won't be able to tune it in with a tuner. Do you know what tuners are? Anyway, also, if a force is the same as light in your theory, why can't we see gravity? Well, you can't see it because it's not big enough rays. Just as you can't see the photons a frog sees. A frog sees more photons than we do. Fact. Okay, so what you're going to ask the question, why can't we see the photons? Well, because the mechanism we have for seeing doesn't see them. Okay, it's not made to see 4 little things. It's made to see 6 little things. Just the rule. Sorry. Probably because there are no answers, only psychobabble. So again, these have all been answered. It's all been stated clearly, and he just deliberately perverts it, right? I mean, these people could quote me, right? They could take actual quotes if they're going to argue what I'm saying. They don't bother with that. And of course, if they do, they'll take the quote way out of context. So, just liars. Pathetic liars. They can't argue the argument. They just build the straw bullshit right here in front of us. Lie, cheat. That's all they got. Suppose I give you a choice of 2 envelopes, A and B. One has twice the money as the other one. Suppose you select envelope A. Okay. What if I gave you the chance to switch envelopes? So this is like, let's make a deal. Cool. So I have my box, and you're saying I can exchange it for a curtain. But I don't know what's in either one of them. Yeah, well. What's the expected value? Suppose I select envelope A. Did I open it? What? Is this some sort of entanglement question? Like the money isn't in the envelope until I open the envelope? Clearly, if I opened envelope A and I looked inside and said $50, I'd know that envelope B either has $25 or $100. It's either twice as much or twice less. So what do I need an E and a B for? What are they? What are they doing, retard? I could draw this one. I don't need an equation. You're a physicist. You should know this. Know what? That it's a waste of time? So I've asked a simple thought experiment, right? I've created thought experiments. You know, and he doesn't want to play with those, though, because they have to do with physics, and he doesn't want to do anything called physics. You know, so I just pointed out simple things that, you know, create a puzzle to solve. And he has absolutely no interest in those puzzles. He wants to, you know, some hypothetical, you know, green stamps he wants to put in an envelope. That's interesting to him, you know. You know, one envelope has 14 more green stamps in it than the other envelope. How exciting. You know, so that game he wants to play, that puzzle he wants to solve. But I've asked the simple puzzle questions about what happens when things interact, right? So if two things let's see, that's surprisingly not perfect. You know, what happens? Do they go through each other? Do they reflect like this? Okay, now it's a possibility they reflect. But isn't there this other kind of reflection you could have where the two things come into each other and they actually do reflect perpendicularly. One goes this way and one goes that way, and that essentially conserves energy. But what happens in the universe if these two interactions could happen? And so that's the puzzle I've asked, and he has no interest in answering that puzzle. No interest at all. When that's physics. Playing with envelopes with money in them, that's not physics. That's for little kids. The advantage of his theory that it solves the problem of induction. Well, stated again by William. He's really stuck on that one. But yes, clearly induction, it gets rid of virtual photons, and it also gets rid of bent space. It gets rid of these fake mediums and these fake forces that you exist with, your fake fields, and turns them into something quite real and quite understandable. The mitochondria is the powerhouse of the torture machine we call life. So, just no way to understand how that's relevant. And he did that to his own comment. I mean, he basically trolled his own comment. So he called it DraftScience, because he can't understand, how you can make models of, you can put a motor on a boat, and he doesn't understand that that's a practical fact, and that the universe can do that. It can make little tiny motors. No, he says that's not possible. All right. So, Zolhar Kunheavy. Once again, I ask you a non-trivial question. So I just love that term. It's just so. Professor Lewin had a spell where he uses that term now, non-trivial. So instead of saying important or relevant, say non-trivial. Yeah, okay. And you get all upset. No, I got upset because it was a dumb question in some context. And I probably explained why it was dumb quite clearly. So, fuck you. It's not that easy to understand everything you're saying. I'm not saying it's that easy to understand everything I'm saying. I'm just saying that each component is not complicated. Right? Now, did you misunderstand this thing? The fact that stuff could reflect this way, or that it could possibly reflect that way? Was that hard to understand? I'm saying the components are not hard to understand. Now, okay, there's lots of components. Okay, I agree. The basic matter force bit stuff is most important. Well, and again, I'm saying that part is so clear. I mean, shit. Two kinds of force. Black and blue, right? Two kinds of matter. Black and blue. The two kinds of interaction. The black matter reacts to the blue force. The black matter reacts to the black force. Inversely. So the blue thing does something completely opposite to what the black thing does when the force interacts. So if blue hits black, it does the same thing as black hitting blue, and vice versa. Okay. Now you tell me that's that's calculus. No, it isn't. So you should clarify if you can. Fuck you. I mean, really. That's all these videos are, is constant clarifications. But I shouldn't have to clarify two. It's definitely a bit of a gray area when it comes to how force bits get trapped. Yes, and that's why the channel's called First Draft Science. And clearly, working on the simulation, trying to optimize its performance, that's what has to be figured out, how exactly the mechanism works. But there is a mechanism and there are rules. There's an amount of density of force compared to how much the thing moves, and there's lots of little subtleties to it. Do I have every single one of those worked out? No, I'm not claiming to. All I'm doing is proving the theory, Theoretically, this concept will create attraction and repulsion. That's all I need to explain into what we call a matter bit. I don't see why you have to be so hostile. Oh, fuck you. 10 years of this crap from you fuckheads. Your arguments for revolutionizing physics is so again, I don't give a fuck about revolutionizing something. It's wrong, it's stupid, and it's silly. Now you're going to call it a revolution because I took God out of Christianity? No, it was stupid. Or let's say I extract the Holy Ghost from Christianity. You're going to call that a revolution? I'm taking error code out of your reasoning. Okay, I'm pointing out where, oh, look, this wave thing is horseshit. Waves are emergent. They don't have anything to do with what's really happening, so just fuck waves, okay? Quit paying attention to waves. The only thing that matters is momentum, direction, and frequency. Alright, physics is going to need a lot of clarification before it's accepted by general public as reality. I don't give a fuck, again, about the general public. I'm talking to people who are supposed to know this shit. I'm talking to them because they're basically walking around lying, okay? They keep saying all this physics works. It really doesn't. The math doesn't work in the two-slit experiment overtly, okay? I mean, the two experiments, you could just look at them. Go look at an electron two-slit experiment and then go look at a photon two-slit experiment. They're using the same exact math. Now, how can the patterns be that different if it's the same exact math? It's impossible. Clearly, in the electron experiment, the light goes on and off in this gradual way. In the photon experiment, no graduation at all. They're fucking blocks, almost perfect blocks. I mean, it's just bullshit. I shouldn't say almost perfect, but I'm just saying they're so little. They're bars of light, clearly. It doesn't fit the math. Again, they don't take the math out very far because the math falls apart at a distance. So again, I'm just saying they're hyping crap. They don't even talk about the two patterns because it doesn't fit any wave mechanics. So I'm just saying, they're saying this is nail in the coffin evidence. These are their words. That's what I'm undoing. I'm undoing preposterous storytelling. They tell you there's many universes. They tell you it's Copenhagen. They tell you this. The photon has radar. Photon split in two, turn into wave functions. None of it has any fucking real hard evidence. They're just fucking stories. And they're stupid. Besides being just stories, they're stupid stories. Anyway, time is something it's a dimension you can warp and bend. It's just horse shit. It's not a dimension, it's a function. There's no room for any more dimensions. You can't make anything more perfect than a circle. It's going to need to be explained and accepted as a fact in many human brains. Well, obviously, yes, and the only way that's going to happen is I have to have the opportunity to humiliate their silly science. So eventually we have to find some physicist we can bribe into being humiliated. No need to get angry throughout this process. Fuck you again. No, I have every reason to be. I don't have to just sit here and say it's okay for you all to be dumb fucks and to be lazy fucks too. I mean, you come here with your stupid comments. I'm going to watch 15 minutes of one video and then ask a bunch of inane questions like he hasn't already answered them all 500 times. I mean, fuck you for that. You can't expect people to just jump on board. I'm not expecting you to jump on board. I'm expecting rational and reasonable arguments about how I'm fucking wrong. I ask direct questions. Will you draw me a picture of an interferometer and tell me where the interference happens? Show me what a single photon does when I shoot it into an interferometer. Will you do that? Yeah, come on. Will you explain to me how wave interference can transport images? That is, you can randomize the pixels. I can just randomize the pixels of an image and then send it somewhere. And it's still going to be the same image after I've randomized the photons. That's not going to happen. Feynman's random theory isn't going to make images go through the slits. So I'm just saying these are simple errors Feynman made, right? He must have known diffraction gradients send images. You say he must have known, but no, he wasn't hands-on. So yeah, he probably didn't know. He didn't know that there's images being projected to all the locations, and that you're not going to make some random theory of photon behavior make images. Anyway, with you about something like this. I mean, he must have known that a gravity lens is the inverse of a magnifying lens, that the rays that need to have more bending get less bending, the rays that need less bending get more bending. can't possibly send anything but one tiny thickness of photons, or the only photons that would have any hope of getting through the lens. So obviously those images from space are fucked up because there's way too much stuff. There's way too much thickness. You can't make any thickness, okay, with a lens that isn't got the right proportions to how much bending it's doing. It's going to take time and exchange of information. Even if I didn't have a counter theory, their theory sucks. And the bonus is that I have a counter theory that not only unifies physics, I mean, it clearly makes clear connections between gravity, magnetism, electricity. It's all connected to the same force, so I've unified it. But it's 2 plus 2 plus 2 simple. So fuck. This shouldn't be a long argument with anybody who's got half a brain. Alright, Inshore, thanks for doing these videos, but please don't be that mean to me. Oh, sorry, you're taking it personally. Anyway, the truth is, Gary and his blind followers, which account to what you can count on one hand, could simulate this in a computer. Well, that's what we're doing. Yes, there's 2, 3, maybe 3 different people working on it right now, jackass. And end the discussion forever. So, okay, if that'll do it. I mean, if you people really can't do theory, right? You have to have somebody draw you actual animated pictures, or you can't understand anything. You're really just saying you're that pathetic, that explaining it isn't good enough. And then you're going to judge other people's physics. You're going to say who's a good or who's a bad physicist, and you can't even model anything in your own brains? Amazing admission. Just program some particles to do just what his theory says, and if he's correct, I've already demonstrated it partially working in an animation. So what I mean, the theory's already been demonstrated to work. It creates repulsion and it creates attraction. And now it's just a matter of creating the right amounts. You should see some of the particles get into square orbits. So, again, he's saying I have to show every piece of the geometric system of the universe, all densities. So we know that there's a huge density difference between, say, the size of a photon and the size of a proton. And certainly when you go with the size of the atoms. So there's no way I can, as a practical matter, model that in small scale and make it at all visible, right? Because if I make the football field, you won't see the grain of rice, on the 50-yard line, right? So we know this can't be done the way he wants it done. You should see some of the particles get into square orbits. Back and forth, square, circular, yes. Maybe if you could actually zoom in on the universe, you might find out that there are no round things anywhere. That like the Earth's orbit is not a round orbit, that actually there's a Planck time and length thing, and the Earth actually does travel a bunch of little straight lines. So, I mean, you could definitely do that with a computer, right? In the sense that clearly the computer's drawing straight lines. All the little photons are released. I mean, all the types, the typeface you're typing here is all a bunch of jagged lines. There's no curves. There's no real curves. You do understand that, right, retard? No, that's theoretically impossible. No, it's not. You can model it pretty easily. Anyway, join with other square orbits and to form matter. Yes, well, forming first, you have to be able to form nucleuses, and then you have to form atoms, and you have to do it in the right sequence. So yes. But of course, in any actual simulation, the particles just bounce around randomly and never stay in one place for long. So again, that's not true. So that's just more of his lies. I've already shown it. So, and nothing bounced around all over the place and did all that kind of crap. They take what mathematics called a random walk. There's no randomness in the simulation. It demonstrates clearly. I mean, I wish I could play more of it. It's just a little bit tough on my computer. But I mean, I could show you different variations where the intensity of the repulsion got so intense, like those 2 electrons on 2 sides of the simulation, and they just kept multiplying the back and, and it was like a laser beam going back and forth between them. Anyway, and stay in one place for long. Random walk. So again, this isn't anything about anything random. They clearly have two different. Clearly what's going to be programmed into the simulation is they behave inversely to the force, and that has a huge consequence. Okay, a square orbit for any length of time, it's basically zero. So again, there's rules that make it not zero. So you want to keep pretending there's no rules to the fundamental universe. Of course there are. But like I said, this debate would be over in a minute. So are you going to guarantee that you'll shut up forever when the simulation is shown right and rubbed in your nose? I'm sure you won't. Somehow shows a computer simulation with a bizarre square orbit phenomenon actually happening. So again, he took my statement about how there's a geometry to, say, crystals in metals, that the atoms must be in some sort of geometry to create a crystal. So even like a diamond, they kind of know what the carbon atom looks like, in terms of its 26 atoms, lined up in a specific way to make a diamond or whatever it is. And he's pretending that that's not geometry. That somehow that isn't just like say if I made a hexagon, that I haven't come close enough to a square. Come on, it has the flat sides, you can get it. Yeah. So that's what he's essentially arguing, right? I mean, you could argue that the energy in the diamond is clearly pushing around the circumference of the carbon atoms that are connected. They're all connected by their electrons, and there's a pure geometry going around the diamond. I mean, that's not hard to figure out. It's real easy to model simple particle mechanics in a computer. Well, you say it's really easy. Sorry. You people complain about look, YouTube can't even make this comment page look good or function well. I have to, 5 times the font size. You have to, the whole page falls apart. It doesn't display on the page. You have to scroll horizontally and vertically. They can't even do that. And you're saying it's easy to do million particle simulations. Oh, I'm sorry, it's not that easy. Million interactions. It's probably easier to model Gary's dumb force bits in a computer than it is to model Newtonian particles. They're close enough to whatever a Newtonian particle is. I mean, the rule are, the only thing those particles have that Newtonian particles don't have is the fact that they can't change their mass or their momentum. So that's the only difference is their mass doesn't change, they don't break, and they don't change their speed. You don't think those are the elemental rules? You think the rules of photons are something different? Well, let me hear your theory on how photons work. Which behave differently, making Gary's anti-Newtonian also anti-Galilean. So again, well, they're clearly not bowling balls or cannonballs. They have a lot in common with them. In certain points in their life, they'll look just like them, but when it comes to the impact, well, that's when they don't look just like them anymore. Therefore, there's really no excuse not to do this. Oh, except everyone, especially Gary, knows already what will happen. So again, I've already shown it. So he apparently didn't see the videos where I've shown it working. Crudely working, in the sense that the reds and the blues went towards each other, and the reds and the reds didn't combine, and the blues didn't combine. So we've already got the concept proven. Anyway, people, see if there was anything else. Okay, so one more. Gelfeld, not sure what you're talking about. It does make sense for the bits to organize in clumps, where the clump moves a lot slower than the speed of any given force bit. They have simulated well on a computer not too long ago, so I'm really not sure why you're complaining. Okay, I don't think the simulation was great, but I'm just saying that Superior Mind guy had a crude simulation. I presented one. There's another guy who I just saw an image of it, and it was already creating atoms. So, Yeah, I mean, the proof of concept has been demonstrated. Argue details, because the concept is already proven. Hi, DraftScience. I've been on holiday, so I'm binge watching to catch up on the last couple of weeks. Where does this hero guy get the idea that paramecium are thirsty? Well, I wish you really wouldn't bring up that crap, but anyway. Sounds as convincing as claiming a virus gets anxious. Well, I mean, I'm just saying that's part of his. He has silly definitions of words, so apparently he doesn't understand the difference between will and what's another word you could use for motivation. What the word will, like if you were to say I have free will, there's two stupid words in there. The free word doesn't mean anything. Okay, there's no such thing as free, right? I can't draw a picture of free. It's just silly. There's only the encumbrance. There's only jail cells, so you can only be free from something that oppresses you. So it's not a real thing. It's unoppression. So you have an unoppressed will. Well, what does that mean? Is it unoppressed by the laws of physics? Is it unoppressed by logic? Is it unoppressed by education? Of course, all those things are in a box you get put in. The smarter you get, the smaller your freedom, right? The less freedom you have to do things wrong when you know what right is, right? So, I mean, it doesn't even make any sense in an ironic sense, the word free. You don't want to have a free will. You want to have a wise will, or smart, or an educated, or informed, a right will. You don't want a free one. Free is stupid and chaotic. It's not organized and specific and control and all of that, the stuff necessary to doing something precise. It's going to be a very imprecise will. Who needs that? Dumb. All right. But yeah, the word will doesn't mean anything because we know our will is just a byproduct of the different influences on us at any one particular time. It depends on how you feel. Do I feel lucky? Changes your will. Anyway, why do you think that other people have first-person experiences? Question mark. So he thinks experience is not something happening in your brain. So we know this Gelfield guy must be a religious kook. Are you a solipsist? So somehow you have to be a solipsist, that is, deny the existence of other people's consciousnesses if you recognize that your consciousness is robotic. No, you don't. Any argument that other people have experiences could apply to matter. Why? Clearly the argument is the experiences are created by a brain, that they don't exist. You're not siphoning experience from ether. So these ether people really are religious people. That appears to have experiences. So again, the argument couldn't be made more simply. The science basically tells you that the brain is where your experiences are, and I jiggle your brain a little bit, and I can change your experience. So I can change who you even are, how you will behave in the future permanently. Also, why do you assume that individual neurons, which by your assumption feel nothing, somehow add together to make feel something? Well, it's just deduction. And again, you can stick them. You can stick it, and I can make you feel something. It's clearly a reflex. Now, you want to say it's more complicated than a reflex. You want to say that the idea of what the brain is tapping into something. Well, no, the whole thing's just a self-creation. It's all happening inside its closed bubble. You want to believe in spirits and souls and some sort of other horseshit, that's your business. But how you give them to something that doesn't have a brain, clearly everything we know about our consciousness is connected to it. I can cut off your foot and you're still conscious. I can cut off your whole body, I can cut your head off theoretically and pump blood into it. And we know it's not your skin or your ears or some other stupid thing that's conscious. And so all you're saying is that the brain isn't just some biological mechanism creating the experience. You're saying it's some sort of tuning fork or some sort of magical ESP device that's siphoning experience from some magical place. The feelings are in the ether, and it's calling them. Why should I believe that? What evidence is there for that dopey theory? All right, anyway. Also, why do you assume that individual neurons, which by your assumption feel nothing? Okay, we did that. There's no reason to assume. There's certainly no reason to assume feelings happen outside, that there's any feeling ether anywhere. No reason to assume that. That qualia emerges as a function of billions of neurons acting together when it could just as well be a property of the neurons themselves. Well, there's just no evidence of that. If I extract the complexity, then there's no evidence that any of the neurons are doing anything. So they can't manifest any action to display their disquiet or their discomfort. And I certainly don't sense it as being, part of this is I'm sampling consciousness, right? I'm sampling it. And there's nothing in the sampling that tells me there's one specific neuron that's doing a feeling. Just one neuron is feeling. And that's my feeling, is whatever that neuron is feeling. It's not my sense of it. I'll say that. I mean, you can make up fairy stories for everything that's a little bit foggy, and that just sounds like fairy story. It seems like a forest, and it has trees. Why do I have to put gremlins in it? We have experiences because we have the necessary functioning brain to feel them, to create them. Yeah. I mean, the brain is creating them. It isn't feeling them like seeing them. Well, I don't know if that's the right way to say it, but what we see is also an illusion, right? I mean, so in a sense, it's like seeing. There is no evidence anywhere ever that the building blocks of the brain that experience sensation also experience sensation by themselves. There's certainly no evidence, and there's no reasoning. Again, so I could take my eye and I could say, look how much physical stuff your brain has to build to turn this chaos into something organized and useful as information, a vision. But what is the vision? Again, the vision is a synthesis, right? What's going to the brain are the pixels from a screen. It's not in the same form as an image, once it leaves the retina, so to speak. So it's being converted into stuff that is translated. It's translated into another form. And clearly the patterns, though, remain. So the information is now in the form of a pattern that doesn't look like me, okay, because it's, on and off signals or some other kind of thing. It's been converted. Just like sound. A nice transition, just like sound. The firefighters calling for money. They need more matches. Whatever. I mean, if they weren't just all such yahoos, you might care, but they're just so, they're just so trying so hard to be heroes. Anyway, yeah, so that's enough on that conversation anyway. I'm just saying that the brain is obviously taking tactile information, these different kinds of organs, and it's creating an illusion. I mean, taste is an illusion of taste, right? I mean, it's not like we're really tasting anything. We're tasting the fact that it has a quality. And it may be taste is a quality we could actually, you can actually smell it sometimes, right? You can smell the taste. So those two senses are sort of tied together. They're different, but they're doing the same thing. They're detecting the same thing. So it's like us having two eyes, one that could see more of the infrared spectrum and one that just did the visible light spectrum. And they're seeing it in a different way. And we could be sensing it through those different eyes, sensing the information a different way. And subtle differences sometimes matter. So subtle differences in smell and taste somehow matter in the real world. It's probably more important than in our world. But there is no quality of taste. I mean, obviously, we're making it a quality. The brain is creating it. But anyway, the senses are just manufactured. I mean, I guess people, maybe if you thought of it that way, they don't think that taste is floating around in the universe, and we're channeling the taste, channeling taste. They wouldn't think that kind of crap. You know, there's little soul patches of flavor in the universe. Flavor is floating around in the universe, and we capture its experience. No, I don't think so. All right, anyway, this long enough video. So, I don't like when it does that. Anyway, so yes, I'll be back probably with some subject-specific videos. Maybe, I don't know. I don't know what I'll do. I'll endeavor to persevere. That's what I'll do.